today is going to focus primarily on vocabulary and multiple representations. But before we launch into those two topics, I want to take a minute to introduce our team. So as you see here, our principal investigators are Dr. Sarah Powell and Dr. Kate Berry. We have our project manager, Megan Carroll, our project coordinator, Jessica Manning-Acebo. Up on the top right-hand corner, you see Katie Barnacle. She is the brains behind your Spiral Educator notebooks that you've received. And we have Jessica Jones, who is our follow-up project lead. We also have some fantastic coaches. We have Carly, Emily, Beth, Daniela, Mita, Michaela, and Allie. All right, so we're going to start with our instructional platform. And our instructional platform has 5 components. Those components are explicit instruction, vocabulary, multiple representations, fluency, and problem solving. And these 5 components are going to be the foundation for providing effective instruction for our students who struggle in mathematics. And the groundwork for everything that we do in math is going to be in explicit instruction. This model that you see here is from the National Center on Intensive Intervention. And we break up explicit instruction with modeling, practice, and supports. And I want you to notice that the supports box is underneath both modeling and practice. That's because we want you to weave those supports throughout modeling and throughout practice. I also want you to take a look at that video icon in the bottom right-hand corner. That is a clue that there is a video that you can find on our website that will walk you through this content. So we have a video that goes even more in depth on explicit instruction on our website for your reference. So let's first dig deeper into modeling. So modeling is a dialogue between the teacher and students. And in modeling, a teacher introduces or reviews mathematical content. So for example, modeling might begin with, today we are learning about division. This is important because sometimes you share things equally. And within modeling, you're going to provide step-by-step explanations. A teacher might model one problem or several, and these examples should be planned examples. But before we jump into planned examples, I want to show you just an example of teacher and student dialogue. And I won't go in depth, but what I want you to notice is the frequency with which the teacher and students are interacting. It's almost like a ping pong game. Teacher, student, teacher, student. I want you to always think about embedding opportunities for your students to respond throughout explicit instruction. So now our planned examples. Planned examples within modeling should sequence from easier skills that lead to more difficult skills. And planned examples in modeling can also include non-examples and worked examples, both correct and incorrect, for students to discuss and observe. So here we have a mix of division equations as well as a non-example of a subtraction equation. So now practice. Practice continues as a dialogue between the teacher and students. And during practice, students should have multiple opportunities to practice with varying levels of teacher support. 2 versions of practice are guided practice and independent practice. With guided practice, the teacher and students practice problems together. So for example, let's work on a problem together using our base 10 blocks. Whereas with independent practice, students independently practice with teacher support as needed. So for example, now you'll practice a problem on your own. Don't forget to use your attack strategy. Our supports should be embedded, as I said previously, throughout modeling and throughout practice. And so when we're thinking about supports within explicit instruction, we're thinking about asking a mix of both high level and low level questions, eliciting frequent responses, and providing affirmative and corrective feedback. So let's look at some examples of high level and low level questions. What is 7 times 9 is an example of a low level question. Which shape has 6 sides is an example of a low level question, whereas explain to me how you solved that word problem is a higher level question. So we want to engage students with a mix of these questions, because if we ask all high level questions, students might burn out. If we ask all low level questions, we're not going to be able to figure out the depth of student knowledge that we need to. Now, for eliciting frequent responses, this doesn't always have to be oral responses. Responses could be written, students could use manipulatives, gestures, drawings. So just a couple examples are: write the multiplication problem on your whiteboard, or in your math journal, draw a picture to help you remember the term parallelogram. So as we're eliciting frequent responses, we can be creative in the modes with which we incorporate. And lastly, you always want to think about providing timely, affirmative, and corrective feedback. So during both modeling and practice, students should receive immediate feedback on their responses. So for example, you did a nice job regrouping, but now let's take a closer look at your tens column. Walk me through your thinking. And as the student walks you through their thinking, you will have opportunities to then provide that corrective feedback. So I want you to remember that this was a quick explanation of explicit instruction. In your Spiral notebook, if you turn to tab 2, you will have a write-up that goes more in detail on explicit instruction, and we also have a video available for you. So moving on from our explicit instruction component to vocabulary, I am going to be running to class in a few moments. And so Sarah Powell will be taking over later, and she's going to dig deeper into vocabulary and multiple representations. But I just wanted to quickly show you a couple examples of 2 of our excellent Spiral vocabulary resources this year. We have our Spiral math glossary as well as word wall cards available for you. Our next component is multiple representations. Those multiple representations include concrete, pictorial, and abstract, which Sarah will go into depth on later during this professional learning. Our 4th component of our instructional platform is fluency. And this year, we're going to break fluency into 2 buckets: fact fluency and computation fluency. Fluency is doing math in a way that is accurate and efficient. That doesn't always mean memorization. But we know that when possible, automaticity can help build students' confidence, and fluency with math facts can reduce stress on working memory. But when we're thinking about computational fluency, we always want to have an emphasis on both conceptual learning and procedural learning. And as students build fluency with computation, they are then doing addition, subtraction, multiplication, division in a way that is accurate and efficient. We have 2 really great fluency resources that you can use this year before we dive deeper into fluency within our professional learning. The first is our math fact fluency activities, and you can find these under tab 5 of your Spiral Educator notebook. These fact fluency activities are paired with brief instructional videos that you can find on our website, or you can use your phone to scan the QR codes. We also, for computation fluency, have two whole number computation intervention trackers, one that's focused on addition and subtraction with whole numbers, and one that is focused on multiplication and division with whole numbers. I have a video on the website that walks you through how to use both of those trackers to provide your students with intervention opportunities within whole number computation. And lastly, we have our problem solving component of our instructional platform. And we will spend a lot of time this year talking about problem solving. But the two big ideas that I want you to be aware of are the use of an attack strategy. And within Spiral, we model the use of UPS check, where U stands for understand, P stands for plan, S stands for solve, and the check mark stands for check your work. We are also going to introduce you to how to teach schemas for word problem solving. And that's just another word for saying word problem types. And you can categorize one-step routine word problems in the categories or schemas of total, difference, change, equal groups, or set and comparison. We have videos and we have activity guides for both the attack strategy and for each of these schemas available for you whenever you're ready to dig into that on your own or with your coach. So be sure to take some time to flip through your educator notebook and peruse through the Spiral website, because we have a ton of resources that we are so excited for you to review. So before we dig deeper into vocabulary, I want you to take a moment and reflect. Which of these components of our instructional platform do you feel the most confident implementing? And with which component would you like the most coaching?
All right, so as Ali just introduced here in Spiral, when you're working with us in the professional learning for Spiral or with your coaches in Spiral, we are going to focus on these five components over there. So that's explicit instruction, vocabulary, multiple representations, fluency, as well as problem solving. And what we're going to do here in this first professional learning today is dive into two of these that are really essential, but also very easy to start implementing. If we started getting into problem solving today, that would be likely a little overwhelming for some of us, and maybe even including myself. So we'll leave that till another time. But these are some of the things that we want to focus on right now that can make a very quick change in how students think about math, and that change will be positive. So, the two things we will dig deep into today are vocabulary, which it seems like many of you are very comfortable with. So, we'll go rather quickly through that section. But then we will also talk about multiple representations. So, there we will get into manipulatives. And I know that you were encouraged to maybe bring some of your fraction tiles or two color counters with you today. So maybe you can do some of the problems along with me as we think about how can we use these multiple representations to help students understand math better. So let's talk a little bit about math vocabulary. If I asked any of you how many math terms is a student responsible for knowing at any one grade level? Let's think about grade 4 or 5. Wonder what your guess would be. Well, would your guess be that a fourth or fifth grade student is responsible for knowing almost 400 different math terms? Maybe that was your guess. Maybe it was less. Maybe it was more. But what you can see here is a understanding of the math vocabulary that students are responsible for knowing across grades K through 8. So none of you are teaching students in kindergarten, but if you were, or maybe you did at one point in time, your average kindergarten student might hear or see during their kindergarten year anywhere from around 120 to 140 different math terms. And that remains pretty consistent in first and second grade. But then we see a very large increase in math vocabulary expectations starting in third grade. And many of you probably have a guess as to why. So if you have a guess as to why we see a large increase there, please open up your chat and type in your guess. All right, so we've got some good guesses coming in here about the star. You are all right. So third grade is usually the first year that students take a standardized test in Texas, and that is the star. And on the star, we get into content that students haven't really worked on before. So our chat talks about multiplication, also talks about division, and there's another one that's really big in third grade, and it has a numerator and a denominator. So fractions is another really important term in third grade. So in third grade, there's a large increase in math vocabulary expectations for students. And so your average third grader should know over 300 terms to be able to adequately participate in their math classroom. And then we see that increase in fourth grade, an increase in fifth grade. And so that's that spot that we already talked about where all of you are thinking about your fourth and fifth grade students likely need to know almost 400 math terms to be able to understand everything that you're talking about, that their peers are talking about, and everything that they're reading and seeing in the math classroom. And that's why for today, we kick off our conversation about vocabulary because there's so much of it. And then continuing into the middle school grades, we see some other uh, slight increases there as we go to sixth grade. A lot of pre-algebra stuff comes into play in the middle school grades, but your students in sixth, seventh, and eighth grade will typically need to know anywhere from over 400 to over 500 different math terms to really do well in mathematics. Now, all of those terms are important because students have to interact with math language in a variety of ways. So today, you all are listening to me. You also are going to get some opportunities to chat in your breakout rooms. But as you listen and as students listen to you in the classroom, there's a lot of language that students have to interpret and understand. And then I imagine all of you, because many of you said you're very good with explicit instruction, so you're engaging students in dialogue about instruction. Means that you're speaking math language, but also your students are speaking math language as they respond to questions, as they do turn in talks with peers, as they provide explanations. So speaking involves a lot of understanding of math language. Students do a lot of reading. Many of you already mentioned the STAR, so students have to read those questions and answer those questions. They also have to read in their textbooks. Many of your students are likely reading closed captions these days. And then students also have to write in mathematics. Sometimes we think when we think about math writing, we're thinking about just writing a numeral like 3 and a plus sign, but we can think about writing words, phrases, sentences, and even paragraphs. And every single one of those things involves a really strong understanding of math vocabulary. And I would say that when students don't have strong vocabulary, it makes some of these ways to interact in the math classroom or all of them more difficult. And if students aren't really understanding what's going on in the math classroom, they're not going to understand mathematics. So, as you work with your spiral coach this year, some things that we'll ask you to think about in terms of math language and specifically math vocabulary are the following. We will be asking you, are you using formal math language? And I'll give some examples of that here in a minute. And then, are you and your students using terms with precision? There's a lot of terms that students will hear about the same time. And what we see is many times students confuse those terms. And so, if you're using formal math language and helping students define and use these terms precisely, students will have a leg up in terms of good math vocabulary. So, with those terms to use precisely, as I said, there's often terms that students might hear at the same time. Maybe it's within the same unit, or maybe it's within the same lesson, or maybe it's in the same 5 minute span in your classroom. And the thing that we have noticed, and maybe you've noticed this too, is that students don't always use these terms with precision. So, an example we see over here on the left hand side is factor and multiple. Do your students know that there's a difference between these terms? And if we were to ask your students, could they use factor correctly and could they use multiple correctly? And another example, do students know the difference between an expression and equation and an inequality? Can they tell the difference among those terms? When it comes to geometry, and you all know this, there's a whole lot of vocabulary that's necessary for geometry. So, do students know different ways that we talk about two-dimensional shapes as well as three-dimensional figures? So, some of the vocabulary they might hear here, and that some of this vocabulary might overlap, might be angle, base, edge, face, side, vertex, and then I'll add to that list vertices. So, do students use these terms with precision? With precision means that they know the differences between or among these terms. So, I want you to think in the activity about one single word. Tell us all the different ways that you can think about the word degree. All right, we've got a really great example that's already come into the chat. So, degree can be a deodorant. Yep, that's a way to define degree. Degree can be the measurement of temperature. All right, I like that. Degree can be the measurement of angles. All right, we've got that. The degree can be a college degree or a high school degree. Some of you talked about a diploma or a level. Someone said to an extent, like the degree to which I agree or disagree with you. Yeah, so there's a lot of different meanings of the word degree. And what I want to get into the next slide is that we want to make sure that we're using this word degree when we need to use the word degree in the classroom, that we're using it formally and that students understand that sometimes there's a math meaning for degree, and then sometimes there's non math meanings for degree. But in the math classroom, this is how we are going to interpret this term. So, some examples where we may not always use informal or may not always use formal language include the following. So, maybe I'm talking about a fraction, 2/5, and perhaps I say, oh, the top number in this fraction is 2 and the bottom number is 5. But that's not really precise vocabulary, is it? That's really an informal way of talking about 2/5. A formal way is saying this is a fraction that has a numerator of 2 and a denominator of 5. Another example here, maybe I'm doing some multi-digit addition and I just tell students to carry the 1. That's not precise. That's not use of the formal math language right there. Instead, I should be saying, okay, now we regroup to the tens place. You might also use terminology such as trade or exchange. In another example here, maybe I'm working with geometry and I'm looking at this figure and I might say, how many corners does the shape have? Nope, I need to be talking about those vertices. So instead of using this informal language that many times is not precise, we want to use the more formal language of math and be more precise with our math vocabulary. Now, there's a cool resource in your Spiral notebook. So I hope that you have it nearby. So pull it toward you. And I know Allie already referred to the Spiral notebook at least once. But now I'd like you to get to tab 3. Tab 3 is all about this language component. And in tab 3, there are several pages of an activity called Instead of That, Say This. And so here's a snapshot of some of the pages of that notebook. And so here you can see instead of talking about a number that's in the tens place, a way to be more formal and precise with our language is to talk about what digit is in the tens place. Instead of reading a number saying 529, no, we don't want to say and until we start talking about decimals. We should read that in a formal and precise way as 529. I am not going to go through the rest of these examples here, but you have some examples for number and operations. There are examples for geometry, for measurement, for a few other examples. But I hope that you can look at some of those today, or maybe talk about these with your Spiral coach so that you can think about some ways where instead of saying it that way, which would be the informal, not precise way to use math language, we should say it this way, which is where we emphasize that formal, precise language. Now, one of the things that was really interesting to me earlier is that many of you said one of the things you'd really like to work on is word problem solving. And that is really cool because word problem solving is one of my favorite things to think about. And word problem solving is really important. Word problem solving is how students here in Texas and everywhere else in the United States show off what they know about math. And that's true in third grade and fourth grade and fifth grade, and then continuing through middle school and high school. And what's one of the most important things about word problem solving? It's understanding the vocabulary in those word problems. And so you might want to think about, well, are my students struggling with problem solving because they have a hard time attacking the word problem and figuring out what they need to do? Or maybe they're having a hard time with word problem solving because they don't understand all the vocabulary in those problems. For example, there's a lot of word problems at grade 4 that use that word difference. Do students know exactly what difference means? So do they know the formal term difference, and can they use that term with precision? So think about some of the vocabulary that's in the word problem solving, and you may be able to use some activities like this. So instead of having students use the informal language, they can use the more formal language of math. Now, one of the things about vocabulary is that we're really building, it's oral language, but it's really we're building language with students. And so to help students build a strong language foundation, students should see words in their written form. They should work on the pronunciation of these terms. We should provide student-friendly definitions to students, which often include a visual image that accompanies that. Students should be able to use words in sentences or paragraphs, and they should be able to practice saying words with a peer or in a small group or independently so that they're really familiar with these terms. And the one thing you'll see in Spiral is we'll really focus on that student friendly definition and that visual image. So, also in your Spiral notebook, in tab 3, so that's the whole language tab, we have included a math glossary of important terms across grades 3, 4, and 5. And there are hundreds of terms here, and each term is presented on the left hand side, and then you see the student friendly definition there. And the cool thing about this glossary is that it is not only available in English, but it is also available in Spanish. So many of you support bilingual learners. And as we think about support of bilingual learners in mathematics, we need to build not only their English mathematics vocabulary, but likely we also need to build their Spanish mathematics vocabulary as well. So we hope that you find this resource helpful. And this resource might be really good for choosing which vocabulary terms you want to emphasize in your instruction and in the resources that we encourage you to have in your classroom. Now, one of those resources that we'll encourage you to have in your classroom is a mathematics word wall. So you have access through Spiral to some word wall cards. Here are two examples here on the left-hand side of this slide deck. And we will encourage you to use these word wall cards to create a math word wall if you don't have one already. But you can create this word wall. Maybe you want to create it and organize everything alphabetically. Maybe you create your word wall and organize words and terms by unit. So here's what we're doing in this unit, and here are some terms that are important for the next unit. But the idea here is that with these word wall cards, you can keep track of what terms have been introduced. So maybe you put the word wall cards on the wall as you've introduced them, and you can teach the students to use this word wall as a resource. It's going to be really helpful for seeing a lot of the visuals and understanding how to spell these terms and then definitions of these terms. And when you have a word wall, it can help hold students accountable for really using the precise language of math, and that's that more formal language. And if you are trying to help your students with spelling of these terms, a word wall is a really great resource to have as well. Now, with these word wall cards, maybe I have them already up in my classroom, then I can really emphasize the vocabulary of math. And I can do this also with anchor charts like this example that you see here. So if I'm thinking about a vocabulary routine, perhaps I show some type of image that has vocabulary terms on it. Here you see an example of that. And I've got a word bank over there to the right-hand side. And I can work with the students to describe this image using some different terms. So maybe I focus here on the yellow equation and I talk about 24 minus 12 has a difference. That's one of my key vocabulary terms of 12. And then perhaps I have students work in partners to describe some part of this image. So maybe one student points out that the green equation has a multiplication sign. Look how students used two vocabulary terms there. And maybe another student points out that 20 divided by 2 has a quotient of 10. So using the vocabulary term quotient there. And then after students have had a lot of practice describing this visual using the word bank and thinking about it in different ways, then students could translate this to the written form. So perhaps they would write the red equation has a plus sign and an equal sign. The sum of 12 plus 12 is 24. So look how much vocabulary I emphasize there just by breaking apart this visual that we provided. So, in tab 3 of your Spiral notebook, there's another resource that you might be interested in. And this resource is called 10 Ways to Practice Mathematics Vocabulary. So, on each page of this resource, you see a different way to emphasize math vocabulary with students. So, it might be talking about explicit vocabulary instruction or using graphic organizers or creating vocabulary cards like the cards that I just showed you. But you also might be interested in thinking about using crosswords or seek and finds, playing memory, establishing an oral vocabulary routine like we just talked about, thinking about math writing, or playing some games related to vocabulary. So, with all of those resources in your Spiral notebook in tab 3, I'd like us to think about the following. If you have a math word wall, I'd like you to share it with your group. So, where is it placed? How did you get the terms? And if you don't have a word wall, where do you plan on putting one? And then take your conversation into how can you encourage students to use this word wall as a tool, and then have some conversations about anything else you would like to talk about in terms of math language. So now we're going to launch into multiple representations. On the Spiral team, we consider this something that is pretty easy to start doing immediately as well, and that is using more multiple representations. You might say, Sarah, what are you talking about? All right, well, when we think about multiple representations, we're thinking about mathematics in the abstract. So that's math with its numbers and symbols, but then we bring in multiple representations, such as those in the concrete and those in the pictorial, to help us really understand what the mathematics means. So you've got that chat open. So I've got a question for you in about 30 seconds. So, first, as we think about the concrete, these are those three-dimensional manipulatives, often they're manipulatives, that we can touch and move around to help students understand math concepts and procedures. So we might be thinking about base 10 blocks or geoboards or fraction tiles or two color counters. What would you say are some of your favorite concrete manipulatives? So let's see. Somebody likes base 10 blocks. Ooh, those are a great manipulative. Someone talks about counters. We've got geoboards, base 10 blocks, base 10 blocks, base 10 blocks. Lots of you love that. Place value coins, the angle legs. Oh, that's a great one. Fraction tiles, two color counters. Oh, fraction strips, fraction tiles, same thing. Fraction tiles, fraction tiles. Oh, all right. That is a great list of manipulatives. And why do you all use those manipulatives? It's to help students understand the mathematics, both the concepts and the procedures of mathematics. But we don't only want to ever use concrete tools. We also want to think about doing mathematics in what we think about as the pictorial. These are two-dimensional flat images that also help us understand math concepts and procedures. So what are some things that are helpful here? Well, pictures, drawings, you either doing some drawing or hopefully your students are doing some drawings. Number lines are a great pictorial representation. Graphic organizers, which I know some of you were talking about for vocabulary, that's a great pictorial representation. And I would also say our virtual manipulatives are a really good pictorial image as well. Often I think virtual manipulatives fall under the pictorial because they're still flat two-dimensional images for students to see. So here are some examples of that. We've got drawings either done by teachers, or students. And then if you're interested in some virtual manipulatives, I was able to put together, I'll just say like a landing page that has a whole host of virtual manipulatives that you might be interested in. So you can either follow this QR code or that bit.ly. You will also find a link to this in your Spiral notebook. But then once you get to this landing page, you could click on each of these sections. So let's say you would like some virtual manipulatives about number and operations. So click on that tab. And then here are some of the all free virtual manipulatives that you might use for number and operations. Some of you said you like base 10 blocks. Well, we've got virtual versions of those. Some of you talked about the two color counters. There's virtual versions of those. And some of you said, I love it when we're using counters. Well, there are virtual bear counters and color counters and shape counters and the Unifix cubes. I'd say those are a counter. So there's a lot of different virtual manipulatives that we can use. Maybe you're interested in some virtual representations around place value. Well, we've got the lovely base 10 blocks there, but later today we're going to look at some place value discs. There's virtual versions of those that you might use as well. And then also today, in just a bit, we're going to get into some fraction stuff. And there's a lot of fraction virtual manipulatives. So fraction strips or fraction tiles or bars, whatever you call it, two color counters, geoboards, the place value discs. All of these things can be helpful for helping students understand fractions better. And then we do all of this. We do the concrete and we do the pictorial to help make sure that students understand mathematics in the abstract. That's with numbers or symbols, or I would also say the vocabulary of mathematics, especially in its written form, is mathematics in the abstract as well. Now, one thing that is important to note here is I want you to look at how we talk about multiple representations and notice how these representations overlap one another. So we've got the concrete and it's kind of overlapping the abstract and the pictorials overlapping there. And then we see kind of a area where all three of these meet. And that's really important. In Spiral, we will always talk about this multiple representations framework, or we will talk about the concrete pictorial abstract framework. We will not describe this as a sequence. We are not saying first do this, then do that, and then finally you get to the abstract. That's not really how math occurs. And I know all of you are probably shaking your head and saying, yep, Sarah, I totally agree. Because if you're talking about math in the abstract, maybe we're talking about that fraction 3/4, you're bringing in those concrete manipulatives to help students understand that. Maybe you're drawing what 3/4 looks like. Maybe your students are drawing doing that. Maybe you've got a virtual manipulative that your students are using. And so all of these representations often overlap. It is not a sequence where we're moving from one thing to the next. And this overlap occurs because you're bringing in these representations as your students need them. All of you are supporting students who struggle at some point with mathematics. And so some days you might be bringing in more of the concrete, or maybe even in the same classroom, you have some students using concrete manipulatives and other students doing it with drawings. All right, so you're bringing in those representations as students need them. I don't want you to think about this as a sequence. Now, as we close our section here on multiple representations, I always want to emphasize that these are helpful for not just teaching the concepts, but also teaching procedures. And many times concepts and procedures overlap so much that we're really teaching concepts and procedures simultaneously. So that brings us to our second breakout room that we are going to do here. And I'd like you to talk about some of your favorite ways to use multiple representations. So in your breakout room, what are some of the ways that you use representations? Are you using virtual manipulatives? Are you using concrete manipulatives? Are you having students with whiteboards and they're doing drawings? Are you bringing in graphic organizers or are students thinking about number lines? Like, what are the ways that you maximize these representations to really help students understand what the mathematics means? But I also want you to think at the flip side of that because sometimes using representations comes with challenges. So, what are some of the challenges that you have? So then the last thing that we are going to dig into are some of the spiral manipulatives that we are going to emphasize with you this year. So the things that we will briefly talk about today are the following: base 10 blocks, Cuisenaire rods, fraction circles, fraction tiles, geoboards, two color counters, and place value discs. Now, for each of these manipulatives, we have several resources that we hope that you will explore. And you can explore them now, or maybe you can explore them with your coach. So, on our Spiral website, which is mathspiral.com, there is a whole series of videos. Here are some screenshots from each of those videos. So, here's a video on how to use two color counters to add fractions with like denominators. There's a video with base 10 blocks. There's a video about using those place value discs to multiply decimals. And there's a video how to use those fraction tiles to help us understand what it means to divide fractions. Those are just a few of the dozens of videos that are available. And then also in your Spiral notebook, you have some one pagers about each of these different manipulatives. So there were 7 manipulatives that we were going to review today. So I'll show you some snippets of the one pager and some of the ways that we can use those manipulatives. So, one of the examples are to use base 10 blocks. I know some of you already said that was your favorite manipulative. So, you're already after my own heart. I think this is a great manipulative, and you can use it not just for whole numbers, like showing 436, but we can also use those base 10 blocks to show things like decimals. Here, I can show the number 3 and 46 hundredths. So, there's a really nice flexibility with the base 10 blocks, not only for whole numbers but also for rational numbers like decimals. Now, some of the things that we can do with base 10 blocks is then we can also use them to add, subtract, multiply, and divide. So here you can see an example with virtual manipulatives, and then you can also see an example with students drawing of hundreds, tens, and ones. So those base 10 blocks might be one manipulative that you consider using. Now, adjacent to the base 10 blocks are things called the place value discs. I have my set right here. When I look at them, they always remind me of a set of Necco wafers, if any of you know that old school delicious candy. At least I think it's delicious. But the place value discs go beyond the base 10 blocks because the base 10 blocks only ever allow us to show 4 place values. When you get a set of the place value discs, they actually allow you to show, I think some our sets show at least 10 different place values. So here, if I wanted to show a more complex number, such as 1,504 and 946 thousandths, I could use my place value discs to first show the thousandths, then to show the hundredths, then to show the tenths. Then I could show my use the place value disc to show my ones. And I'd say, oh, I got to show 4 of those ones. Then I'd say, okay, now I'm going to show the tens, but no, I'm not. Not in this number. I'm not showing any of those tens. Let's knock that place value disc out of there. But then I could use my place value disc to show the hundreds and to show the thousands. And so then I could read this place value, this number by its place value. And then I could also do more complex calculations with adding, subtracting, multiplying, or dividing. We have a lot of videos on how to use these place value discs. And so check out the Spiral website for videos around addition of whole numbers, addition of decimals, subtraction of whole numbers, subtraction of decimals, and then same thing, multiplication of whole numbers, multiplication of decimals, and then division of whole numbers and division with decimals. So I hope you will check out some of those videos to see how flexible these place value discs can be. They've quickly become one of my favorite manipulatives. Now, another big thing in fourth and fifth grade is an emphasis on fractions. So we just talked about two manipulatives with place value. Now we'll talk about some hands-on materials and virtual materials that we can use to help students understand fractions. So fraction tiles are a really nice manipulative to use. Fraction tiles emphasize fractions according to their length. And so I can show the fraction 3/4 here using my fraction tiles. First by showing the whole. That's always important. I always want to have a reference for what is the whole. And then I could have divided that whole into 4 equal parts, but then focus on the numerator to then emphasize that I'm going to show 3 of those 1/4 parts. I can also use my fraction tiles to help students understand decimals and percentages. Many time fraction tiles are labeled on the back with those other representations of rational numbers. And I can also use these fraction tiles to then show equivalent forms to 3/4. So right here, you can see a visual that 3/4 is equivalent to 6/8. And why does this show the length model of fractions? Well, here I can see the length of the value of the fraction 3/4. So it really gives me a good idea of the value of that fraction. So just as we would plot on a whole number line 4 or 13, when I do that, then I can see that 13 is greater than 12 and 13 is less than 14. If I place 3/4 on a number line, or if I show 3/4 with my fraction tiles right here, I can understand the value of 3/4. I see that 3/4 is greater than 1/2, but also less than 1. And I see a comment coming in from the chat that fraction towers are also very helpful. I really agree with you. I like the fraction tiles as well, fraction towers as well. And you can do many of the same things with fraction towers as you could with the fraction tiles or fraction bars. Now, fraction tiles are also really flexible as we get into the operations of fractions. So for example, if I'm trying to help students understand, well, what does it mean to add this fraction of 1/2 and this fraction of 1/4 and add those together? I could first show the fraction 1/2, and then I could show the fraction 1/4. And here I'm going to talk about, well, now I'm putting together the numerator or the parts of these fractions. So I'm going to take that 1/4 piece and I'm going to add it. So now 1/2 plus 1/4 has a sum of 3/4. I could do the same thing with subtraction with my fraction tiles. So I could say, okay, here's a set of 7/8. And from that set, which I'm going to subtract from that set, I want to subtract 2/4. And I'm not going to do anything with that 2/4 down there. I'm just going to use that for my reference to understand how many I need to subtract. So here I can see that I need to subtract what ends up being 4/8. So I could say, oh, 2/4 is equivalent to 4/8. So I'm going to subtract those. I could also do some comparison here. I could ask myself, what is the difference between 7/8 and 4/8? Well, I see the difference are those 3/8, or those 3/1/8 pieces. So the difference there is 3/8. I could also use my fraction tiles for doing some really cool stuff with multiplication. So here, if I have the problem 1/2 times 3/4, so I could say, oh, I need to figure out what 1/2 of 3/4 is. So I'm going to show 3/4, and then I'm going to figure out, well, what is 1/2 of each of those 3/4 pieces? So here's 1/2 of 1/4. Here's 1/2 of that 1/4 piece. Here's 1/2 of that 1/4 piece. So 1/2 of 3/4 equals 3/8. Some of you probably are doing this problem with me with your fraction tiles, but you could also do it with virtual fraction tiles as well. And then we can also get into division of fractions. So here, 7/8 divided by 1/4. The question I should ask myself is, how many 1/4 pieces can I make if I have 7/8? So here I would like to show 7/8. And I could say, all right, I can fit 1/4 piece into 7/8. I can fit a second 1/4 piece. I can fit a third 1/4 piece. And then I bring in my fourth 1/4 piece, but you know what? It's not full there. I can only make 1/2 of that next 1/4 piece. So when I have 7/8 divided by 1/4, that is 3 1/2. Now you might say, Sarah, oof, that was a lot. Well, guess what? On the Spiral website, which I just saw the link drop into the chat there, mathspiral.com, or at least I think it's about to drop into the chat, we have videos on how to use these fraction tiles to explain addition, subtraction, multiplication, and division of fractions. Now, another manipulative that's adjacent to those fraction tiles that you might be interested in using are the Cuisenaire rods. These allow a little bit more flexibility in student thinking because students can show one fraction, but show it in multiple ways. You can't do that with the fraction tiles. There's only one way to show 2/3, but if we do this with the Cuisenaire rods, there are multiple ways to show 2/3. So here I could first show 3/3 and then show 2/3 of that fraction, but I could also do this in different ways, and maybe you can explore what those are. Here, if I was interested in working with decimals, I could use these Cuisenaire rods to show tenths. So here I have shown 3/10. Now, some other fraction manipulatives that you might be interested in using include the fraction circles. So here's a way to use my fraction circles to show the fraction 2/3. I could also use those fraction circles to show a decimal. So for example, here I have shown the decimal 9/10. And here I have shown the percentage 75%. Then I could use the geoboards. This is another great manipulative for fractions. When I was using those fraction circles, that was the area model of fractions. The geoboard also helps me show the area model of fractions, because with the area model of fractions, I can take any area, whether it's circular, whether it's rectangular, or really any other area at all. And when I can divide that area into equal parts, I can show a fraction or sometimes a decimal or a percentage. Now, some of you probably have geoboards. Here's my geoboard right here. Well, it's a little hard to see in my camera, but it's blue and I see those nasty, evil rubber bands in there. And so if you find those rubber bands to be evil and nasty, just like I do, that's where virtual geoboards can come into play. So there are several virtual geoboards linked on our Math Spiral virtual manipulatives. Here's an example of one of the digital geoboards that you might choose to use. These are great for geometry, great for measurement, but also really cool for fractions. So here I have a fraction divided into 12 equal parts. I can also use these geoboards to do all that stuff with geometry or angle measurement like I had just mentioned. And then another fraction manipulative that you might be interested in using are the two color counters. I love the two color counters for their versatility. They can be used to show a fraction of 2/3 because here I can show a set and then show 2/3 of that set is red. So the two color counters get into what we call the set model of fractions, where we can show fractions according to their set. I can also use these two color counters to do a lot of the things that we did with the fraction tiles for multiplication of fractions. Here I could say, well, here's a set of 3/4, and I want to find 2/3 of that set of 3/4. So 2/3 of 3/4 equals 1/2. Or maybe I want to look at some other ways to use those two color counters. So on the Spiral website, you will see examples of adding with fractions, subtracting with fractions, both with like and unlike denominators. And then you will also find examples of multiplication of fractions as well as division of fractions. So I really hope that you will check those out. If not now, when you are about to teach those things with your students. So I said that we had a one pager for each of these manipulative pages, and that is totally true. So here is what they look like. So right now, I would like you to open up your Spiral notebook, and now we are going to tab 4. All the language stuff that we talked about was in tab 3, but now I'd like you to move to tab 4 there. And in this tab, we are going to think about these multiple representations. So you can find the one pagers. Maybe you can find the one pager for the base 10 blocks, and then it shows you different ways to use those base 10 blocks. Or maybe you can find the one pager for something that we didn't talk about today. Maybe some of you have already seen these, but a really cool manipulative that we have emphasized lately is this Poppet hundreds board. This is really great for counting or for addition and subtraction. You can also use it for multiplication and division, which I think is super cool. And maybe you have some other ways that you can use this Poppet tens 100 board to help students, particularly with their place value understanding. So those are some of the manipulative one pagers that you will see in tab 4 of your Spiral notebook. Now I want to leave a little bit of time for the exit ticket. So you are going to answer some questions on this exit ticket, such as the following. You can see them there. This feedback is really important for us. It's feedback on the professional learning session, but it's also really good information that we will share with our Spiral coaches. So, one of the things we will ask you about today is to pick an instructional focus that you want to work on with your coach. And the big three that we'll first talk about are explicit instruction, mathematics vocabulary, or multiple representations. And then we'll also talk about ways that you will collect student data related to that focus. And so, are you going to think about formative or summative assessment data, conferences with students, or work samples? Thank you so much for joining this first Spiral Professional Learning of our year. We're really excited to work with each of you, and your Spiral coach will be in touch soon. So please finish the exit ticket, and we will see you again in just a few weeks.